Welcome to this special tutorial. Today we'll be looking at similar triangle. It's a very important topic, very important in geometry. So under it, we'll first know the definition. That's how we know two triangles are similar. We'll then know some similarity postulate and theorems. We'll get to triangle proportional segment theorem, mixed segment theorem, exam questions and solution on the theorems, and ratio of areas of similar triangle, exam questions and solution on ratio of similar triangle. Finally, geometric mean of triangle, and we now solve question on that also. This topic is very wide, so it seems to take at least six or 5 videos to cover this. So, and I advise you to follow it sequentially this way, so that you get everything on the topic. So we start with the definition. Okay, similar triangle. Two triangles are similar if the corresponding sides are of the same ratio. So, or if the ratio of the corresponding, two triangles are similar if the corresponding sides are of the same ratio. So, and we normally denote that's this, we use the symbol this means similar in geometry. So once you see this symbol, it means similar. So let me now use these two triangles to illustrate what we just defined. So if you have triangle ABC and triangle PQR, if the ratio of the corresponding sides, assuming the size of this is, let's call this A, B, and C, while this, let's call it P, R, and Q. So we are saying that if the ratio of the corresponding sides, so if you assuming, for now we don't know, A corresponds to Q, so we say if A over Q is the same as, maybe if B corresponds to P, B over P, or finally if C corresponds to R. So if they are of the same ratio, remember we are taking two, we take two at the same time, we can't take the three. But if any of these, once the ratio of the corresponding sides are the same, you know that the triangle are similar. So let's now go over to the similarity postulate and theorems. The first postulate, that's the only postulate we have here, is the AA similarity postulate. AA similarity postulate. The postulate states that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. If two angles, so assuming for triangle A, if assuming I'm giving A this and maybe this, if it's the same as, that's congruent, maybe this, the same angle. So if two triangles have the same the same interior angle, you know that the triangle are similar by angle similarity postulate. That's what. So meaning that we need to check if the angles are there, whether they have the same two angles inside the triangle. And finally, remember the main thing is that the ratio of the corresponding sides must be proportional. So once this happens, we now check, okay, maybe if you are given, let's take this as C, this A, and Y this B, this P, this small r, and this Q. So we now check Okay, look at this one angle, one hash, this is double hash. So C corresponds to Q. Yes, maybe let's go. C corresponds to Q. Y P. P corresponds to B. And finally, A. A corresponds to R. Do you get? So we need to check if the two interior angles are the same. Finally, we now check the, which implies that the ratio of the corresponding sides. So I'm saying that C corresponds to Q and B corresponds to P, and finally A corresponds to R. So once the angles are the same, then the ratio of the corresponding side must be the same, making it a similar triangle. So the next one is the SAS similarity theorem. SAS similarity theorem, it states that if an angle of one triangle is congruent to an angle of another triangle, and then if the length of the sides including these angles, if one angle, okay, including these angles, so this should be x, are proportional, then the triangles are similar. SAS. So I'm saying that, assuming you are given, okay, let me label this as, okay, this C and this B. So if I take this as the included, remember an included angle is any angle between two sides, given sides. So assuming here is the included angle of this, so here is Q and this is P. So we are saying that if they have the same angle, see, they are the same, then if the ratio of the sides including this angle are proportional, then they are similar. So if after checking the angle and also if the sides are proportional, I'm saying that if now maybe let's assume Q is proportional to C, so I'm saying that then if C over Q is equal to B over P, then they are similar. We still solve questions to illustrate this. So that's what it means. So we check the included angle first. Then we now check if the ratio of the sides are proportional. You know that they are similar. So the next one is side, SSS. So if you are given three sides, it's the same thing as what we've said. The ratio, that's the main definition of a similar triangle. So once the ratio, all the three sides are proportional, you know they are similar. So assuming if here is A, there is C, and this is B, Y this is P, this is R, this is what? Q. So any randomly, if C over Q equals B over P equals A over R, then the triangle is similar. So once any of them, it could be C over P. So anyone, once the ratio are the same, knows that they are similar. So finally, we now have the last one, which is right triangle similarity theorem. So from the name, is for right, is only applicable for this theorem, is applicable for right angle triangles only. So it says that if an acute angle of one right triangle is congruent to an acute angle of another triangle, then the triangle are similar. So I'm saying that if you have if this is the acute angle, maybe for this is the acute angle. So if what is here is here, then the triangle are similar. So you know that the ratio, you now check, therefore the ratio of the corresponding side must be equal. So that makes it a similar triangle, makes the two to be similar. So that's what it states. So let's now go over to example. Let's check whether this triangle, okay, look at this question. This question will help us to understand. We have like 5 questions that will help us to understand the similarity postulate and theorems. That it is similar, that the two are They told us that the two triangles are similar. So, but which postulate or theorem? So the first thing we'll have to check, this, okay, if you notice, this angle coincides with this. We have triangle DBE. So they have this common angle. So the other one, we are looking at this, it seems we are given two sides, this and this. And the two sides are the side including the angle. So meaning side angle SAS. So it seems the answer is SAS, because if you check this DBE, we are given C and A. The included angle is B. Why ABC, we are given D plus C and A plus B. So the answer is SAS. The second one, we are asked true or false if triangle ABC is similar to triangle DBE. Triangle ABC is similar to triangle DBE. Okay, this one we ask whether they are similar. So looking at this, you know, it's the same triangle as the former one. So we need to check the ratio of the corresponding sides to know whether they are equal. If they are equal, then they are similar. So I'm saying that if you see 6 corresponds to 8, I'm saying that side DB corresponds to AB. So I'm saying 6 over 8. Let's know whether it will be equal to 12 over 17. Looking at this, they are not equal, because if you do 6 times 2 is 12, but 8 times 2 is 16, not 17. So it's not equal. So the answer is false. So that's it. This ratio of the side must be proportional. So the next one, which of the, so we are given which of the following is correct. Whether triangle ABC is similar to DEC by AA similarity postulate, SAS and SSS. So okay, let's check. Here we are given, if you notice, this angle is the same as this, yes, by vertical angle theorem. So, and we are given side angle side, that's XAS side, this side angle and this side. Why this side angle? And so the problem is there is not enough information here, because even if we do 3, if you assume that 3 over 45, that's 3 corresponds to 45, AC corresponds to CE. Let's know whether it will be equal to 9 over 8. So do you get what I did now? I assume that this AC corresponds to CE, but looking at this, they are not equal, so it's off. So let's now check the other way around. 3 over 45. 3 over 3 corresponds to 8. And 45, 9 corresponds to 45. Not correct again. So it seems they are not similar, so the answer is none. They are not equal, so the answer is none. So the next one, we are given which of the following is correct. This is by, okay, that same, okay, let's check. We are given side angle side. We are also given, but here we are not given this side, but we are given this. There is a problem. Supposed to know this. So I don't think that SAS will work here. So the answer should be none, because this, they must give us included angle, assuming it's this, but they gave us this, so this is wrong. So the answer is none. Some student will make mistake by choosing this one, but the answer is D. So the next one, we are given, are the two triangles similar? We have two triangles here, ABC and AED. So what we check the ratio of the corresponding side. Okay, as I'm seeing 30 here, I'm seeing 10. So let's assuming 30 over 10. We need to remember this is all the sides are given in this triangle, so it must correspond. So 30 seems corresponds to 10. So also the bigger one, which is 6, the bigger side seems corresponds to 2, which seems correct. And finally the 18 corresponds to 6. So the answer is yes. Check it. 30 correspond because they are of the same ratio. The answer they will give us the 3 will give us the 3. So the answer is yes, they are similar. So we stop here. We go over to